Thank you. So the context of this talk is the SYCL project. SYCL doesn't mean anything, but if you want to go look at what it's supposed to do one day, then you can go to the GitHub site where I keep it. And the purpose of the SYCL project was to create high-quality modules for implementers of Common Lisp systems. And such modules exist, and I wanted to improve the techniques with respect to algorithms and data structure whenever possible. I also wanted to use a more modern, more maintainable coding technique. I wanted to improve documentation and ultimately take these modules and create a new implementation, modern implementation of Common Lisp, if you want. In terms of previous work with respect to the loop macro, almost all implementations use a derivative of a loop macro that was written at MIT in 1980. So 1980 is prior to the Lisp standard, so there's certain features of the Lisp language that it doesn't use, for instance, C loss. They did actually try to make it somewhat extensible anyway, in that whenever a clause starts with for, then it branches off to several different functions depending on what follows the for and so forth. They use no particular parsing technology as far as I can tell. It's just testing loop keywords and analyzing it basically ad hoc. As far as I can tell, most Common Lisp implementations use a derivative of it, with the exception that I found of C Lisp, which has its own implementation, and I believe the code generation function for C Lisp loop macro is 900 lines in one function. Most implementations that I've looked at use a derivative of MIT loop that has been modified by Symbolics Inc., presumably for the Genera system. Now, because of the limited modularity of MIT loop, it doesn't come as a separately maintained module. Each implementation has kind of copied the code into a file, and then modifications started happening in different ways in different implementations. Some of these modifications are cosmetic, just change the package names and indentation and things like that, but there's also more substantial modification going on. So as a consequence, one of the big problems that I see with MIT loop is that it's no longer possible to maintain it as a separate module, and it has to be maintained separately in each implementation that uses it. In addition to that, there are some other problems with the MIT loop. For instance, it is non-conforming. If you take this code here, it loops for I from 0 below 10, some I finally print I. The Common Lisp standard clearly says that I does not take on the value indicated here. So it should stop at 9. But MIT loop and all the implementations that I've tested that use MIT loop, they print 10 instead. So that's non-conforming behavior. Now, attempting to fix that in MIT loop would be a major challenge. Less severe, but still a problem, MIT loop accepts non-conforming code. At least it ought to be up to each implementation to decide whether this code should be accepted. Now, the difference between the previous example and this one is the previous example is a clear violation of the Common Lisp standard. This is not, because the Lisp standard says the behavior is undefined if you have, if you have a main clause before a variable clause. And when the Lisp standard says it's undefined behavior, an implementation is allowed to define that behavior. And so basically every implementation that uses MIT loop will define it to means something. And what it means is pretty clear, but it's still not a conforming program. I'm not going to go into the details of what it means to be a main clause and a variable clause and stuff like that. You can read the standard or the paper that summarizes it. So in our implementation of the loop macro for the sickle system, I made a couple of decisions to improve the situation. For instance, I used a modular parsing technique known as combinator parsing. That was initially developed for Haskell. And I represent clauses as standard instances. When I say standard instances, it means instances of subclasses of standard instance. Which is what you get when you say def class. Yeah. Some people would call it, oh, I use CLOS classes, but every class is a CLOS class, so I'm not using that terminology. And I use CLOS generic functions for semantic analysis and code generation. So combinator parsing, in fact, I do not use currently a fully featured version of combinatorial parsing. I use an approximation of it, and I'll get back to that later. So like I said, it's something initially developed for Haskell. What it is that you have elementary parsers that can parse a single word or an optional word or something very simple like that. And then there are combinators that take these elementary parsers and combine them like into sequences or into alternatives. So that's a very modular technique in that if you have two clause types that both start with 4, you can have parsers for each one in different packages, if you like. And they can still be combined because they will be tested one after the other until something succeeds. Okay? Whereas in MIT loop and certainly in CLisp loop, all of that code sort of needs to be more or less together. There needs to be one function that recognizes it's a 4 and then branch off to different 4 parsers. And so it's much less modular that way. So clause parsers parse individual clauses into instances of the class named clause. Okay? And different clause types are instances of subclasses of this general clause. And if you remember the loop macro, there are some clause types that admit the AND loop keyword. And for those, I also have, each clause has a list of subclasses. And all of these being standard instances, it's quite easy to use generic functions applied to them for semantic analysis and for code generation. So initially, I parse each clause into one of these instances without taking into account the restrictions on clause order. Why? Because it would fail to parse with some very strange error message saying, I don't recognize this keyword in this context. But it's by doing it this way, I have an explicit pass that checks the clause order, and I can actually give an error message that says you're not supposed to have a main clause before a variable clause. And semantic analysis also checks that there is only one type of accumulation. You cannot say both collect and sum, for instance. It will complain. And the code generation is done by a bunch of generic functions that extract information from these clauses and subclauses where those exist, such as variable binding information, termination test, iteration, and other information that you need in order to plug it into the expansion of the loop macro. So the benefits of this technique compared to what's been used in the past, like I said, the modularity is improved, and the reason for that is both the modular parsing technique and the use of generic functions, so that you can write auxiliary methods for those. So it's easier to extend. You do not have to intervene in the body of code that I wrote. You can write a separate module and a separate package, and that could be a different clause type that you can add to this framework. You just have to write a parser for it and use the functions to plug it into the general parsing framework. You need to write methods for extracting variable bindings and so forth. But it doesn't have to be in the same module as the one that I wrote. Now, just a short word about bootstrapping, because this question always comes up. A lot of implementations are bootstrapped from some presumably simpler language like C or C++. And so what typically happens is that people come in and say, oh, I don't have CLOS yet. How can I use your loop implementation? And this question to me is now becoming more and more bizarre. What does it mean to not have CLOS yet? Well, that supposedly means that you do not bootstrap your Common Lisp system using a Common Lisp system, which to me is extremely strange. Bootstrapping a Common Lisp system on C or C++, with some exceptions, like CLASP, which needs a LLVM interface from C++. But let's, except for that, there seems to be this idea that you have to create your Common Lisp system from C or C++. But there are so many good Common Lisp implementations out there now that it would be too painful. It is too painful. I tried it to actually try to implement these modules using something less than the full Common Lisp language. So this loop macro, the implementation of this loop macro, uses full CLOS. And CLOS presumably uses loop. And besides, this one uses loop as well. So that does look like a circular dependency, but it isn't, because you can bootstrap this on a host Common Lisp system and generate your own Common Lisp system. It was so many times where I found myself writing some functionality for expanding loop that says, okay, loop for, oh wait, I'm not supposed to use loop. And eventually I got tired of it and said, I can't live with this kind of restriction. I need the full language to implement these modules. So I will ultimately write a paper about bootstrapping instead, and be better use of my time. Anyway, future work. Currently, clause parsers basically fail silently, and that's kind of intrinsic in the technique of combinator parsing, because a particular individual parser doesn't know whether an other individual parser will succeed. So it cannot give an error message because it might not be an error. And that's kind of intrinsic. So the way I'm planning to handle that is to add clause parsers that succeed for slightly incorrect clauses. And when they succeed, they give an error message. Okay. Possibly I might do this in 2 steps. That is, I use a few parsers for performance reasons. If it succeeds, everything is fine. Otherwise, it uses a second set of parsers with more error reporting. Like I said, I used an approximation of combinator parsing because at the time I started writing this, was a couple of years ago now, I couldn't find any existing Common Lisp combinator parsing frameworks. Now I'm aware of at least 2. And those are more complete in that they allow full backtracking. Currently, my approximation of it requires a particular order between the parsers, which is obviously not so modular. So I'm going to replace my parsing framework with some existing fully backtracking framework. I might also investigate other parsing techniques that are also modular. In particular, early parsing is another modular technique that doesn't require pre-processing the way LALR does. There's some code refactoring that needs to be done. The current code is pretty large, partly because of documentation, but also because of lack of refactoring. And I need to document how to write extensions. Like I said, you can write your extensions in your package and then plug it in, but I haven't documented how it's plugged in. And I would like to thank Dave Murray, who's not here this time, unfortunately, for reading early versions of this paper. Thank you very much. And this is also a good time to ask questions about SYCL in general, I think, if you don't have any questions for Loop in particular. Yes?
How's SYCL going in general?
I'm sorry?
How's SYCL going in
SYCL
general?
hasn't been going anywhere for 3 months because I've been working on the papers for ELS. But Schaffmeister is using it, the compiler framework for CLASP. So we haven't detected any particular problems with that as far as I can tell. Oops, yeah, okay. I have a hard time hearing. Can somebody repeat that? Yes. That is one of the frameworks that now have full combinated parsing, I believe, or so I've been told. So, yeah, I need to. There's a couple more CL combinators, something like that also use it. Yes, I'm aware of the libraries that exist, and I need just to evaluate them and see which one is best. Yes. Yeah.
Could you say a little bit about the runtime performance of the code that's generated by the loop, or is that even an issue?
That's not an issue. The runtime performance is as good as it gets. It inserts the declarations wherever that's possible, and otherwise the expansion is just a tag body with go-tos or with goes and stuff like that. So there's no particular runtime issue here.
What about the compilation time?
I actually haven't checked it because that also is not that much an issue unless, of course, you have a very slow interpreter for your bootstrapping or something like that. But I'm going to wait and consider that later when it becomes an issue. So yeah, I mean, it's bound to be slower than something that doesn't use as much genericity as this one. And of course, all the combinator parsing framework does backtracking, and it might fail, and it might come to the end of the clause and then backtrack up and try something else. So bound to be slower. Yes. Yes.
You said there is an issue when bootstrapping Common Lisp from something other than the Common Lisp. I have two questions. The first is like a more general one. Can I just grab your version of the loop and import it as a different package inside my implementation?
Provided your implementation is complete already, yes. It needs to have a loop already and needs to have a full CLOS implementation.
So let's assume I just grab a first version of, let's say, still bank Common Lisp, and then just load your version of loop.
Yes, but there's no particular point in doing that unless you, I mean, the situation for doing that would be that, yes, you're an SBCL user, but you are particularly unhappy with the way SBCL does loop. Sure, then you can do it, and that would be fine. But the more general setting would be that you would have one host Common Lisp implementation that you use to load this code in, or read this code into generate code for your system and then run your system. That would be the more typical use case. Yes?
Have you found any, or how many bugs
I don't know. I mean, the only real bug I found, because I haven't been investigating MIT loop that much. Are there any bugs in the standard? It might not be entirely possible. No, there might be some. There might be some interesting cases that don't make sense. Yes. Well, I shouldn't say it can't be implemented. I should say there could be some considerable ambiguity as to what ought to be done. Yeah.
I have a question with regard to these ambiguities in the group. When I try to read the documentation, there's many times I don't understand what it's trying to tell me. Is a byproduct of your work actually documentation of what group does?
Yeah, in some ways it is, because you have very explicit parsers that say exactly which kind of syntax is acceptable. But it is, unless I write complete documentation for it, it's kind of inside the way the code generation is done. So I probably wouldn't recommend that you just try to understand it from that.
Any more questions?
What's the modules are already there is compiler and loop?
Format is almost done. I started the sequence stuff, which was the first thing that I attacked, but that's going to have to be completely rewritten because I now have a technique for automatically generating special versions of those methods, if you want. They're not quite methods, based on what Cleaver can do now. So it's all going to be rewritten completely. I don't have an initial list in my head. Yes?
Just curious, extensibility. I'm just trying to think what I would extend if you just give me, for instance.
Well, a typical extension would be the one that Christoph Rhodes did for SBCL for general sequences, like for X being the element of such and such, where it could be any kind of sequence. And then he plugs in his extensible sequence framework there. So, for instance, a flexi chain is now a sequence in SBCL, stuff like that.
Are your extensions then constrained in some way, or is it sort of? I guess I should look at it.
No, they're not. They're not constrained in any ways. If you write a parser that will parse your kind of loop, then or your kind of clause, then they're fine. Yes. Sorry. A form? Yes. 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 Yes, maybe so. Yes. Yes.
It's a book is basic in language. How well is tested in your implementation? How good is all corner cases and so on?
I'm sorry. I have a cold, so I have a hard time.
How well is tested? What the corner tested?
For this implementation? Well, I ran it through all of the ANSI loop test body made by Paul Dietz. And I had to remove some of the cases because they were incorrect according to the standard. And I added some cases that were not tested for. And so my implementation passes all of those tests. Okay. Thank you.